Good morning, everyone. My name is Aditya, and I am a consultant. I founded a company called DevOps Nexus, and we consult a lot to SMEs and startups around their systems engineering and DevOps needs. A little background about me. Before this, I was leading the infrastructure for BrowserStack. I don't know how many of you know BrowserStack. Okay. So I was leading the infrastructure for BrowserStack, and before that, I was in DirectI. All right. Um, so when we consult startups, when we consult small companies, infrastructure is one of the very basic pain points that we are often taught. Uh, Most common thing is that, hey, we got a bunch of developers, we got a couple of people in marketing or sales, but we don't have a DevOps, so we don't know how to scale, or the application was not designed to be scaled. Application was designed to be, just a prototype, which eventually grew into a full-blown application, and several similar problems. What I'm going to tell you right now in this talk is something which you already know, but it's something which we almost always tend to overlook. How many of you actually saw what happened with GitLab a few days back? Right? Okay, quite a few. So for those who don't know, um, GitLab, one of the folks at GitLab by mistake dropped the production database. Now, mistakes happen, and that's an acceptable risk if you are operating a company. The bigger problem in that case was that since there was no analysis of what their infrastructure is, they had no sense that their backups actually do not work. Of the 4 or 5 different kinds of backup that they were taking, many of those were inactive, never ran since months, or ran and produced 0-byte files or something like that. So a lot of problems around that. There was no analysis of what to do and when. So basically, what I'm trying to tell you is that you need infrastructure gap analysis. And I'm going to tell you some bold bullet points which you should probably look at and incorporate in your company, in your organization. I'm going to try and recommend certain open source tools to you which you can look at. And hopefully these tools will help you in building a very robust infrastructure. Okay. So when we do infrastructure analysis for companies, we basically focus on 4 major areas. First one is architecture, security, infrastructure management, and monitoring. Right? Very common areas, and I'm pretty sure that if you have built a simple web application, you will need these to some extent. By the way, I encourage you to ask questions, interact. If at all you want to put a bullet point, if you want to tell me that there's a better tool out there, or if you want to tell me that there's something more which can be done in this area, I would happy to hear from you right now also. So please feel free to talk. In terms of architecture, first thing that we need to know is, can our application fail over? In case one of the instances goes down, will my customer see impact? Right? How do you do that? Easiest way is to use a load balancer. DigitalOcean recently launched a load balancer service. Almost every cloud right now has a fairly reasonably good load balancing service. If you are on an infrastructure that does not have a load balancing service, you can also look at HA proxy, Nginx, bunch of open source tools are available out there. If you are in a state where you do not have a load balancer and you're going for other fancy methods like DNS round robin, I would strongly recommend against that. There are multiple reasons of not using DNS: caches, bad TTLs. So as far as possible, try to have the control of load balancer in your hands, either via a cloud or via setting up your own tools like HA proxy or Nginx reverse proxy. Next up is horizontal scaling. Whenever you build an application, try to make sure that that application is horizontally scalable and prefer not to scale it vertically. Do you know what is horizontal and what's vertical in this area? Okay, quickly. Horizontal means that you add one more instance. Vertical means that within the same instance you increase the resources. So as far as possible, try to add more instances. Why? Because that will help you reduce the failure points. As much as you spread out your application, that's better for your availability. Um, Single point of failures, try to avoid single point of failures. Now single point of failures, not only in terms of service, but also in terms of personnel. Let's say tomorrow one of your key developer, is missing on a holiday or something like that. Can you manage your infrastructure without him? You have to reach a stage where your dependencies on a single service as well as on a single person is not there. You should not be dependent. For services, you should build in reasonable defaults. I'll give you a very good example. Have you ever visited any major e-commerce website, Flipkart, Amazon, right? You see the recommendations there. If that recommendation tool goes down, you won't actually even realize it because they have a default setting up. So instead of your recommendation, some default set of things will come up which will be prompted to you to buy. So such defaults actually are very helpful. So try to build in defaults as much as possible and avoid single point of failure. Offsite backups. How many of you here take backups of a database? How many of you are not taking backups of a database? I cannot believe this. One of you is lying. Okay. Backups of database is one thing, but you always have to take offsite backup of your database. How many of you are taking offsite backup of your database? See, the hands are reasonably less now. The reason why I'm saying so is that there will be circumstances where you will need an offsite backup. How many of you have heard of code spaces? Nobody? All right. Quick short story. Code Spaces was a small company which used to provide personal space where you can put your code related files. Some guy hacked them, compromised their security, deleted everything from their cloud infrastructure, including their databases and backups. So offsite backup is very important. The company eventually shut down, by the way, because they had nothing. They had no idea who their customers are, who to charge and what to pay. Nothing, zero. So avoid such catastrophe and have an offsite backup. It's very cheap and it's very helpful. Next up, SSL termination at appropriate places. Now SSL termination is something that what happens in most of the cases is that whatever web server we are running, Apache, Nginx or whatever, we will tend to put our certificates there, right? That's a practice which I would strongly want you to avoid. There are two reasons. One, from security standpoint, you're actually keeping the certificates there where everybody who has access to that machine can see the certificate, right? Which is bad. And next up, you are actually offloading the processing for that certificate, for that encryption to your Nginx, which is not really actually required. What you can do is, whatever your load balancing provider is, be it DigitalOcean load balancer or whatever cloud provider you have, they will have a facility to offload the SSL at their end. Both the advantages of security as well as processing you will get if you use the SSL termination in such a manner. All right. And last point in terms of architecture is basically customer latency. So what happens is that, let's say my startup started 4-5 years ago and my customer base is in India. Now I would most likely be in Singapore region because at that point of time, 5 years ago, there was no India region, and all of us were in Southeast Asia. And if Southeast Asia, then we'll be either in Singapore or in Eastern Asia, which is Hong Kong. Singapore gives you 40 ms of latency, right? Now what happens is that as a customer, when I open a website, every asset will take at least 40 milliseconds. Even a 0-byte asset will take a 40 milliseconds, right? And if you have ever done web development, you will know how many assets are there, right? There are literally hundreds of images in a simple website, hundreds of images, JavaScript, CSS files. Just move your application to India will actually save you that much time. So try to co-locate yourself as much as possible to the nearest region where your customers are. Here I'm assuming that you're not CDNized. If you have a CDN, then also it's actually very beneficial to be close to your customers as much as possible. But otherwise, CDN is also something which you can look at. Okay, so these are the broad bullet points I have for the architecture. About security, how many of you actually have a password-based SSH access to your servers? Okay, go home, change them now. Reason being, password-based access are very much prone to brute force attacks. So go for simple SSH key access, which is actually very simple. It will take you less than 5 minutes to configure it. Okay, try to do that. How many of you share the credentials? I'm pretty sure nobody will raise the hand. But okay, so having spent a considerable amount of time with startups consulting, I know that most of you do. I'm pretty sure that there will be one guy who will be, hey, I lost my key, can I use yours? Right? So avoid that. If somebody has lost their key, ask them, wait, that's your punishment. Okay? Unless production is down, make them wait. It is very important to not share credentials, not only from security, but also from accountability standpoint. Okay? So each user should have their individual keys. Insist on that. SSH brute force, it's, how many of you have ever noticed that when you log into your SSH, there's one line saying that XYZ number of failed attempts, right? Okay, few people. How are those, from where are those failed attempts coming from? Have you ever tried to realize that fact? That failed attempts are coming because there are certain people who are after your life, after the life of your SSH server. So best way to avoid SSH brute force attacks is to use something simple called deny host or fail to ban. Both of these are open source projects. Very simple daemon, you just start them, and if they see an extended number of attempts, failed attempts to log in into your server, they are going to block that IP. All right. Also block the root access. See, as a third party, I don't know what all users are there in your servers, right? But I know that if you're running a Linux-based server, you will have a root server. You will have a root user, right? That's the first point where I will attack you. So always block SSH access from that user, and it's very simple. You just have to make a one-line change in your SSHD config. Okay. Next up, firewalls and VPCs. Whatever service provider you are at with, every operating system has, every Linux-based operating system has a IP tables firewall or firewall D, one of these two. Even in default config, these are very helpful. So they'll make sure that no unnecessary ports are allowed. They'll only allow probably SSH and port 80 or 443 depending upon how you've configured it. And that will also help you avoid a lot of attacks. All of you have used databases at some point of time. I'm assuming that bit, right? Did you ever remove the default user of the database? Only 1 to 2 people. So if you are on Postgres, there is a Postgres user which is created by default. If you are on MySQL, there is an anonymous user, right? Similarly, almost all databases have a default user. You have to delete that user because this is a well-known attack vector. If I know that you are on Postgres, I can just start brute forcing the Postgres user, and it's very much possible to get access to your database if I have that particular information. Another thing is that at a lot of times people actually will not change the password for the default user because they might actually don't know that there is a default user in place. So at those times, it's very helpful if you can just delete the user at all and create a new application user for your own particular application. CVE watches. How many of you know what is a CVE? All right. CVE basically is a list of vulnerabilities in a particular tool. Okay. So assuming that you are running on a particular operating system, be it Red Hat, CentOS, Debian, Ubuntu, whatever. If you are on PHP, then you will be running the PHP package. If you are on Ruby, then similarly. So CVE is something which actually maintains the list of vulnerabilities that are there in a particular software or operating system or default tools or packages that you're using. It's always helpful to keep a watch on these CVEs. Otherwise, what will happen is, if you have heard of Cloudbleed is what happened somewhere a week or 2 weeks back. How many of you use Cloudflare, the DNS, the CDN? How many of you use Cloudflare and don't know what Cloudbleed is? Perfect. Just to give a short overview again, Cloudbleed is a bug in Cloudflare, was a bug in Cloudflare, due to which you could actually get a lot of sensitive information from any website that uses Cloudflare. And that is actually a very big percentage of internet. If you have a lot of websites, a lot of popular websites uses Cloudflare and they were bitten by the bug. But if you have been proactive on your CVE list, if you know that these things are coming in place, then you have to act accordingly, probably change the passwords and so on. So these things are important to make sure that your infrastructure is secure. All right, infrastructure management. How many of you actually check the server utilization? Do you know how much your servers are getting utilized? What do you think is a good amount? Do you guys check load, memory, things like that? So you have to make sure that your servers are appropriately utilized. What I have observed a lot is that most of the companies don't actually realize that they are heavily underutilizing. So they'll boot a big instance thinking that, because see, how much RAM our laptops usually have? 4 gigs, 8 gigs, sometimes 16 gigs, right? Right? And due to that mentality, when we actually start servers, we automatically think that 8 gig is something which we will need to run a simple PHP or Rails application, which is not true. You need a lot of RAM because you open 50 Chrome tabs and you have a GUI. Servers don't have that. So you have to make sure that you are not underutilized. That will save you a lot of money, as well as that will help you in capacity planning. You need to know what your application is capable of. For example, if you have a memory leak, okay, and you are already on 8 or 16 gig of server, then you might actually not realize it until it blows up your entire application. But if you are on a properly planned infrastructure, properly capacity planned infrastructure, then it will be very quick, it will be faster and trivial to detect that there is a memory leak, and you can fix it in an early stage rather than waiting till the end. Okay. For server utilization, what tools I recommend, I would, how many of you have used Graphite? Graphite is an open source tool, and then it has a daemon known as Diamond. Diamond runs on your server end and it posts the data to Graphite, and you can actually see very nicely plotted graphs and analysis on how much utilization is happening in your server. You can see that CPU is only 10% utilized or RAM is only half used and so on. Graphite, one more reason why I recommend Graphite is that Graphite is very flexible. So not only you can plot your infrastructure matrix, you can also plot your product matrix, your customer retention matrix. You can say that, hey, my site was visited 100 times today. Out of those 100, 10 people signed up. Out of those 10, 6 are paying. You can plot all these data points using Graphite. It has a very simple protocol, and I strongly encourage you to use it. Open source, feel free. Configuration management and infrastructure provisioning. This again is something very common that I've seen with smaller organizations, that when you begin, you actually set up your servers manually. While that's okay for start, when you are setting up your first or your second server, when you actually subsequently are on your 5th, 6th or 7th servers, and if you are still doing things manually, then that's a problem. From two standpoints: A, eventually you're going to forget what you did, and that's going to be a problem. B, when you need to scale, you need to do things quickly, and manual way is not the quick way. Also, now recently, after looking at GitLab, I've added a C which is GitLab. Don't try to do things manually because there's a high probability that you will miss something, you will mistype something, and that will blow up. So, as much as possible, try to introduce a configuration management tool early. My recommendation is to use Ansible. Ansible is an open source tool again, and the advantage of using Ansible is that it's written in YAML, which is almost English. So even if you take that YAML spec to a non-technical business guy, he will be able to understand what you're doing, and that provides a very good visibility about what you want to achieve. Now this actually has two components. One is configuration management, and second one is infrastructure provisioning. Configuration management is something which a lot of people can relate to. So if I talk about automatically setting up servers, you guys will know that, okay, there is something known as automatic setting up, and you will subscribe to it. Now the problem is not only setting up a server. Problem is now that we are in cloud, we are actually using infrastructure as a code, right? We can actually say programmatically that I want this much infrastructure, I want these many nodes with this capacity. And I encourage you to stop doing things manually and use the APIs, use the SDKs. Terraform by HashiCorp is another open source tool which is very good at doing this. If you are on DigitalOcean, then DOCTL. Other vendors, of course, have their own libraries and SDKs. Use them. Next up is central logging. One problem with logging is that you don't need it until you absolutely need it, right? If everything is good, you'll never need logging. But the moment something goes wrong, you'll need all the logging that you can get. And often the problem is that the guys who are actually coding the application might actually not have access to that particular server, that production server which actually threw up error. Now you have two options. Either you keep on, grabbing the logs and emailing to that poor guy, or you give him the access, which again is something not very easy or recommended because of security reasons. So central logging is actually a savior in this case. What central logging does is that there is a central server where all the application sends their logs, and a person who wants to debug can actually look at only this particular logging stream. And now these streams are actually very well packaged with nice GUI and analytics tools on top of them. For this, my recommendation is to use ELK, Elasticsearch Logstash Kibana. It provides you very nice GUI and analysis capabilities. Another alternative, if you don't want to go this route, is to use Greylog. Greylog is yet another open source tool. I have personally seen people liking Elasticsearch Logstash combo a lot more than Greylog, but both are very good tools. Next up, QA and deployment automation. So how many of you are still running the deployment command manually rather than pressing a button? This is absolutely lie. I don't believe you guys. You are saying that only 2 guys in this entire room are doing manual deployments. You're not running commands, you're clicking a button. Dude, you're going to put me out of business. Come on, raise some hands. Okay. So I'm seeing this many hands now. Rather than this. All right, I'll buy that. How many of you have heard of Jenkins or Circle CI? Right. So those who did not raise hands this time, what are you using? How do you fire your automated scripts? Command. Got you, right? Right. So commands. So what I want to tell you is that try not to type commands. Try to automate this entire thing. Now Jenkins is a very good open source tool. There are a bunch of others out there in this space. What they do is that you code it once, test it out, and then from the next time you don't type a command. Typing a command has high level of high probability of going inaccurate. So next time you click a button, there the probability of committing an error is much lower. Hopefully you will click the right button. So do that, and again it's an open source tool and very popular tool. So you will find a lot of how-tos tutorials to do that. Okay, rollback testing. How many of you have a rollback strategy? Let's say you deployed something, it went wrong. What do you do next? How many of you have thought of that, that hey, if something goes wrong, I can roll it back? Do you have that sort of strategy in place? 1, 2, 3, 4, okay. Right. How many of you have a strategy and have tested it also that it actually works? Okay, fewer hands. Right, so what I'm trying to say here is that not only you should have a rollback strategy, you should also test it. And not only just a git revert or something like that, test it end to end, in the sense that what will happen if you have done a migration, what will happen if you have committed to a CDN, if you have pushed your assets to CDN, can you get your older assets back? You have to do all these things to make sure that your rollback is complete end to end. All right, don't just rely on, hey, I can do a git revert and it will be good. No, it will never be good. So do that. Cloud access permissions. Now, if you are a team of reasonable size, I'm pretty sure that more than one of you have access to the dashboard, the cloud dashboard, right? And if you have that, then you need to have proper access control, in the sense that if you have 10 production servers, not everybody should be capable of deleting those, right? Not everybody should be capable of removing your database from your cloud provider's end. So as far as possible, you need to restrict those accesses. You need to log what actually happens, right? Their APIs are very helpful if you are going that route. So try to log whatever happens and then use central logging to basically see who's logging in and who's doing what. And if you see a login at 3 a.m. in the morning, then you know that something is not right. Monitoring. Now, this is something which a lot of people actually know that they need to monitor. But what I've observed in my consulting stint is that people don't know what exactly they need to monitor. Almost everybody here would probably be monitoring CPU, RAM, disk, regular things. CPU, RAM, all the regular things. But I want you to monitor things like latencies, things like making sure that your application is actually reachable not only from your database or data center, but also from other locations. You have to start monitoring these things. Nagios is a very good tool. Again, open source. Isinga is another open source tool. They are very good at these things. So go ahead and use them. Service monitoring and server monitoring. Try to monitor both things, not just the server parameters, but the service parameters. Like I mentioned, latency. Often a rise in latency actually gives you a very good indicator that something is not right. Historical data and trends. Again, I mentioned Graphite some time back. So I encourage you to use Graphite to plot what is happening in your system. If you see a steady rise in your latency usage, if you see a steady rise in your RAM usage, then you know that code that is being committed is not right. You're writing suboptimal code. So that's a very good metric to judge the quality of your application. And lastly, alerting and escalation methods. Almost everyone accepts email alerts, but email is not good enough. Use a proactive alerting mechanism like phone, pagers, push notification. Now that you have smartphones, you can use push notifications. So use such tools, and pushover is one such tool which can provide you push notification. It's $5 for lifetime, so you can try looking at that. There are PagerDuty and similar other tools. In this area, I found that most of the tools are paid actually. So yeah, that's about it. A quick walkthrough or what I have observed. If you want to talk about more that how some of these metrics may be helpful to you, then you can reach out to me and using my email ID or Twitter or website. We have a sample report which we actually give to our customers, and that report is free to download. Please feel free to have a look at it, and you will find a list of 40 points that we go through with our customers, which will help you in improving our infrastructure. Thank you very much.